Hi there, I'm here with Daan Moreels, co-founder at Magnax. Happy to have you here.
Thank you very much, Davio.
Co-founder, what does that mean?
So Magnax is a company that we started in 2016, 15. Basically, it started when I met somebody at the school gate at that time. That was Peter. And Peter was basically developing a new kind of electric motor in his garage, which sounds a bit funny, but I remember that I was thinking, okay, it will be something, let's check it out. Mm-hmm. And he was basically creating in his garage a very large version of a new kind of electric motor, which we call axial flux, which was at that time...
Sounds like Back to the Future. How is it called? The flux capacitor.
Flux capacitor. Yeah, that's not the first time that I hear that. So axial flux is the name of the technology. Mm-hmm. And he was already in touch with Ghent University, who was doing research at that time at this new technology. Yeah, he was working on this technology, making a prototype. It didn't work yet, but I quickly saw, okay, there is quite some potential in this new technology. Mm-hmm. And at that time, I was out of my former startup, Cloudalize, and was looking for a new kind of project. And we decided to collaborate. He could keep working on the technology, and I could start discovering the market. At that time, it was still focusing on wind turbines, so large versions of this axial flux motor / generator.
What's different about the motor? Because it sounds very futuristic, axial flux. What is different about it?
So it's already known for quite some time. Already Faraday in the 19th century knew the topology, the principle of the motor technology, but it was very hard to make it work. And also the mass manufacturing aspect was impossible at that time. So it's different. So a normal motor is basically two cylinders in each other. You have something which rotates, the rotor, and something which is standing still, the stator. Two cylinders in each other. So our topology is a bit different. So we also have a stator in the middle and two spinning rotor discs on each side. So it was known that it's more effective topology electromagnetically, but difficult to make it work. So it's only the last 15 years that startups started to work on it, research started to work on it to actually make it work.
And is that what we see in electrical cars these days as well? Or is that still something that needs to happen? Like if I'm not sure what car you drive, but let's say you drive a Tesla or anything. Can we find that in a Tesla?
No, you can find it in a few hypercars at the moment because our number one competitor, YASA, was earlier in this technology development and is already developing products for Koenigsegg, also for Ferrari. They have been producing motors for the hybrid version of it. And YASA was acquired by Mercedes a few years ago. So you will see this technology first for the AMG's versions.
And it's still in the expensive version because it's still an expensive technology, I'm guessing.
All technology starts mainly high-end. You can also see it with the strategy of Tesla, which started with the high-end, the Roadster, and then the Model S, Model 3, and so on. So new technologies are always quite expensive if you start out because production is limited and you have benefits, but you need the tooling, you need the mass manufacturing, you have to reduce the cost by volume.
Even though it's already been here for 15 years, it's still quite new in terms of production and in terms of usage, actually.
Yeah, from a technology point of view, it's quite new indeed. So it's only the last 15, 20 years that companies, mainly startups, started to working on it. And also for us, we do not expect final products of our technology before 2027 or something.
Okay, and how come?
Because new technologies take a long time to develop. So I don't know if you know the technology readiness levels. It was originally invented by NASA.
Okay, that I didn't know.
TRL 0, 1, 2, and so on. So
it's until 9, I guess.
Until 9. So 0 and 1 is basically academic research. 1, 2, it's more like starting to make some prototypes that kind of work, but then you have to mature them until to working prototypes that can prove themselves on a test bench, for instance, TRL5, then TRL6 is put this new technology into an end application. In our case, it's a car. So it takes 15 years to mature a technology to something which can be trusted and which is ready for the market, basically.
And it's because the technology is hard or because the market is slow?
Because the technology it takes a lot of time to iterate. And if we talk about AI, we're going to go back on that topic later, because that will change a bit with the rise of AI. It's a physical thing. It's a combination of electromagnetics, thermals, mechanical stuff, things that can vibrate. It's a physical product. You cannot just use prototypes in final applications, because you also have things like noise and vibration that you have to take into control. You have certifications that you have to adhere to. So it's a long trajectory to put hardware into something that can be trusted.
But you expect that every future electrical car will have that type of motor?
Well, if it has benefits, you can expect that it will be used much more often, of course. So what's the benefit of this technology? For a certain power rating, you have 1/2 to 3 times lower weight. It's also much thinner. So if you smaller, thinner, it has similar efficiency, but in some applications more efficiency. But where is lower weight or compactness an advantage, especially in things that fly and move, like cars and especially aerospace? Their weight is very important, of course.
Yeah.
So there we can expect the use of axial flux motor technology more and more, but it will take also time, because you also have to prepare the technology for mass manufacturing. So it means you have to make sure that you can do every step in the production process via standardized automated production processes. These are things that are produced in the millions in China already, for instance. So it takes a lot of time also in terms of design for manufacturing, design for costing, design for assembly, and so on. So it's a completely different world compared to the software world.
Yeah, where you're coming from, actually, or more or less Cloudalize, which is, or was that was also software, or was that?
It was a combination, because
you had your own GPUs there then, because that was basically how I remember the business was. You rented out GPUs a bit in the cloud avant la lettre.
It is software because we were creating a stack, technology stack, where every layer did a certain application. So what we did was the development of GPU accelerated cloud desktops. So some kind of virtual workstations, which is becoming more and more apparent nowadays. And it was an automated provisioning platform, basically, that was able to assign certain resources to a virtual machine. For instance, a certain amount of GPU, depending on the application. So for instance, an architect uses less GPU than, for instance, a videographer, to give you one example. And you could, as such, pay for a certain amount of resources. Pay as you go, basically.
Yeah. All right, cool. So now Magnax, Cloudalize. Magnax is focusing now on 2 markets. You've been in the technology sphere a lot right now. How do you see, because AI is not necessarily something you're working with, or you have been working with?
You would think so, but we see also the rise of AI in the hardware world. To give you one example, what we talk about the digital twin. So if you are able to predict the behavior of a new kind of hardware, for instance, an electric motor, as much as possible before you start prototyping, that has tremendous benefits, of course, because...
So you build the motor in a
you create the
software,
motor
3D,
at the moment,
simulated?
Yeah, at the moment we cannot build a complete motor yet in a digital form. It's more like certain parts, because the combination of the mechanical part, the thermal part, the electromagnetic part, it's quite difficult. So there are a lot of parameters coming together, and we still need like real life prototyping, where we can learn a lot from. that go back into the models to reinforce learning around these models. But we can see that it's also maturing, and we also see that companies like ANSYS, Siemens are also introducing little pieces of AI to make the life of a design engineer, electromagnetic engineer, easier to test things faster, to iterate.
So the cycles will become shorter. Basically,
exactly,
before building it, you can already test it virtually and see what the impact of the design choices are.
Exactly. And indeed.
So, and would you say that, or do you expect that this will become the future? So that you don't build prototypes, but or how do you see that happening?
That's very difficult to say, of course. It depends a bit on the complexity of the thing. An electric motor is a very complex situation because what's coming together, a lot of variables, mechanical parts, vibration, thermal influences. For instance, if you run the motor, it becomes hot, then it can have an influence on the insulation around the coils, for instance. There are thousands of variables that you have to try to predict, actually. So for that, it will come
within conditions that can be very extreme as well.
Yeah, indeed. But if you create, for instance, like a simple lamp, I can imagine you can do most of it already virtually, and then very high chance if you create a prototype that it will basically perform as you expect. While for very complex new technologies like axial flux motors, I think there will be a lot of prototyping still to be done. But eventually, I think in 10 to 20 years, a lot of also complex hardware will be able to you will be able to predict it, to model it completely, and use a lot of information research that's available everywhere, and that the AI will be able to address and also understand very well. And
so are you now in Magnax now looking into AI or investing in it, or is that more as a part of the software stack that you're using for design, or both?
Yeah, at the moment it's part of the software stack, so it's a bit pushed from the suppliers like ANSYS. But we are also now thinking of how can we basically assemble all information that we have around this new technology and see, okay, can we put that, for instance, in a private cloud and put a GPT around it and see, okay, is there a possibility to basically use the smartness of an AI to offload the thinking from our engineers? Because humans, for them, it's very difficult to combine thoughts. They can have meetings, of course, and they can prepare information during meeting and try to combine different disciplines with each other. But it's still difficult for an electromagnetic engineer, for instance, to 100% understand a mechanical engineer, because these are different disciplines which they have to combine. For an AI, that will be much more easy, of course. If you say that an AI of today has like an IQ of 100, it can be specialist in electromagnetic design of anything, for instance. But
so, and what is that you want to do then? Like because you say private cloud, because your IP is something that you want to protect. That's your main asset as Magnax. Exactly. So that IP, you don't want to share that with OpenAI or Microsoft or whatever. But what you want to do is leverage the power of what you say GPT, which is, okay, what are, and the questions you want to ask them is, and how can we improve it? Or what would this do? Is that the kind of things that you want to do? Also sort of simulation, or what is it that you expect to get from such a...
The expectation will be to speed up the iteration process. Basically speed up the development process. And at the same time, it's also not easy to find specialists in certain disciplines. For instance, finding electromagnetic specialists. We have 19 or 17 nationalities on board in Magnax.
And how many people are you?
Around 45 people. Okay. So it's a very international situation.
Yeah.
So we have to harness people from everywhere around the world to get to our competences. So my expectation is by the use of GPTs in the future that we can address that and basically go much faster in the development process. Which is very specific for hardware and quite different when you compare it to software development.
Yes, exactly. Yeah. But so you're seeing that. So your software, the stack that you're using is implemented. You're thinking of using it. At the same time, another thing that I'm seeing or we're seeing is that it's also steering hardware already more and more. To give an example, you have Figure and the Tesla Optimus and robotics, basically. Is that something that you have been looking into, or what do you see there? Or is that something, do I have to see that as two very different things?
That's it depends a bit. We are deeply specialized from Magnax side on axial flux technology. So the electric motor is our thing. We are also now expanding it to more like the EDU, the electric drive unit, the powertrain, which includes also a gearbox and then power electronics. And that power electronics, which is controlling the motor, is then connected to a vehicle control system, which is basically already the software. So if you talk about Optimus, humanoid robots, you can also say that an electric vehicle like a Tesla is also some sort of robot, which we will see in the future that you see more and more autonomous driving vehicles. People only want to be transported from A to B and still work on their Snapchat. They are not expecting to drive, especially not in heavy traffic, of course.
I like what you say, working on Snapchat.
Working or playing a bit. Robotics is indeed the future, but you can also see an autonomous driving vehicle as a robot, so to speak.
So there you expect in the future that you might have those engines and that you have let's say an intelligent part to steer the engine.
It's incorporated. The electric motor itself, you can see it as a dumb part. But the optimization of the whole powertrain to increase the efficiency as much as possible, depending on the situation. So if you have a taxi driver functionality and you only drive very short rides, then you can maybe reuse or reconfigure the powertrain system as such that the efficiency is higher in that particular situation. If you are driving a lorry from A to B over long distances, then you can, for instance, say, okay, we're going to activate only one motor when it's driving on the highway. And then when it has to go hills up, then we need 3 motors to be activated. And as such, also increase the efficiency of the complete system, which is also directly connected to the battery systems. The fewer batteries that you need, the better, of course, because batteries are expensive. So,
and maybe to tap on that a little bit, because electrical engines, batteries, it's very related. There's a lot being said about solid state batteries. The last thing I heard is that Toyota said by 2027 we expected to have it in mass production. Do you believe that?
Yeah, that's not impossible. Innovations are going very quickly. Toyota has been always a bit slow in the conversion towards electric cars. They went more and more into the hybrid applications. Yet, I think they are one of the companies with the most patents globally, Toyota. So they can use a lot of their patents and knowledge to go quickly also in the direction of solid state batteries. So it's not impossible.
And will that be a big difference then? Because I'm not an expert, but what I've heard is that solid states are 1, less dangerous, 2, lighter, 3, more energy dense, and 4, if we break through, cheaper to produce as well. So basically the holy grail.
Yeah, especially the cheapness is important to increase or accelerate the advent to electric cars. The battery part is a very expensive part, so if you can reduce the costs as much as possible, that's an advantage. But with all new technologies, solid state is now today very, very expensive. It will also have to get into mass production to get under a certain cost threshold. So it's a continuous evolution in innovation. And also there, I think that AI will help a lot with quicker iterations, experimentation, virtual experimentation. What are the right combinations of the cells? The chemical part, I believe that an AI will become one of the best chemists in the world, because it will not only understand everything around a certain topic, but will also have access to all the research around a certain topic that we cannot expect that from a human.
A human cannot consume all of that information, yeah.
There are maybe hundreds of thousands of papers written around specific types of cathodes. If an AI can see them all and comprehend everything around it, then you can also expect that it will be able to combine it with other innovations and come up with combinations that are really disruptive, which is basically impossible for a human team to do, at least at the speed that we expected. Yeah.
So coming back to robotics, is that something that you're looking into, or how do you? Because it's also engines. It's also it seems to be close. Have you been following it?
I have been following it. There was an axial flux motor that was created by Ghent University for the use of humanoid robots or other kinds of robots, cobots and so on. So we have been looking into it, but we are not sure yet if an axial flux motor would be an optimum use for robotics, but there is a high likelihood of it.
What does it mean you're not sure yet? Is it because the cost versus the traditional motors wouldn't be interesting enough, or what does that mean?
Because if you introduce something, it has to have certain benefits, of course. So in our case, we clearly see the benefits of axial flux for larger motors, for high powerful motors, for up to 200, 200, 300 kilowatts. There we have a very clear advantage in terms of weight and compactness. Is that also the case for robotics, where the power is much lower, where you basically expect, okay, we have to have a certain amount of torque, but the power level is different, the use is very much different. We don't know yet. We have to investigate that, but it's not impossible. It's very likely. Yeah.
Yeah. All right. Cool. And so. Just on the topic, not per se in terms of engines, but how do you believe? So you've seen maybe Figure, the Figure bot and Optimus. What do you think about that?
I think Elon Musk or Tesla started with it because Musk saw the opportunity and that the technology was maturing enough to make it possible. And then I believe that Brett Adcock, the founder of Figure, got to know it and also started at the right time his company. So I believe it's the right timing for it, because you see a lot of converging technologies coming together. The motor actuator technology is getting better and better. The battery technology is getting better and better. You see also that sensor technology is getting at a certain maturity to be small enough to combine a lot of sensors in a small thing like a robot. You see also the rise of AI, so you can add a lot of smartness to something mechanical. So that's a lot of converging technologies coming together at a certain time. And this is, in my opinion, the right time for starting the development on these humanoids.
And so it seems to go very fast if you like Figure publishing new videos every X weeks. It seems to go very, very fast. Do you think that's it's dress up, or do you feel that it's really going that fast? And how will that? Like I saw that they have a deal with BMW to already help them in production of cars. Do you think that's a realistic path, and that it will go at the same speed?
It's going very fast indeed. Now they are 2 years old, I think, Figure, and they are now at their second generation, or at least second generation, which is a big upgrade compared to their first generation. So if they keep continuing at this speed, I can imagine that we will have like useful robots for industrial applications in a few years. Not saying household applications.
That you say industrial. Why industrial and not household?
Because the tasks are more obvious. Operators can be interchanged by that. To give you one example, Amazon has now 1.1 million robots working already in their warehouses and so on. That's slightly more than the amount of employees that they have. Okay. So that's also an important thing. They start to also use humanoid robots or experimenting with it because the whole world in warehouses it's made for humans. Mm-hmm. So if the humanoid is smart enough, you can basically start displacing a real person with a humanoid robot and doing similar tasks basically. For households, that's a different scenario, of course, because safety is important. I can imagine if you put a humanoid robot in a household and the humanoid robot steps on a baby, then it's over and out. Worst case scenarios, much more difficult to control in a house than in an industrial environment, of course.
Which is a more predictable environment, basically.
Right.
Yeah.
Right. Yeah.
Okay. And so, but yeah, I think I believe a lot that a lot will happen once we really get at scale there, because there's also some kind of a feedback system, because right now all AI systems are trained basically on data that we've produced, but at the moment that they're becoming part of reality and they can learn from reality, which will, in my opinion, give a new accelerator to the development. But still, maybe something a bit political, seeing that you are a deep tech, you've been doing that in Europe for quite some time right now. Mm-hmm. I have the impression, and not from your words, but from other people, that Europe might not be the easiest place to do these kinds of things. Mm-hmm. How have you experienced that? And looking then at robotics, which is in Europe and even in Belgium, we have quite a strong history of manufacturing companies. But if you look at that new wave of deep tech and manufacturing, for instance, motors or robotics, we don't see a lot happening. I would say almost nothing, which is, in my opinion, might be the biggest opportunity that we're losing here. How do you look at it? How do you experience that from a Magnax point of view? And how do you think that results and moves forward to robotics or other manufacturing
that's a very good question, of course. So the question is actually, why don't we have a figure in Europe? And why is this created in America? The same question you could ask, okay, why is Google and Tesla, why did it start in the US and not here in Europe? It's a combination of factors, of course. The risk-taking factor is important, so it's much more...
As a part of the culture, you mean?
Cultural thing. You also see like, the ecosystem of Silicon Valley
is talent density and money.
Attracting, indeed, not only best talent, but also most of the VC capital is still located there, which is inherently related to the location. And in Europe, if we look at our own trajectory, hardware, we don't know many companies in Belgium who are basically only specifically focused on developing hardware technologies. Fundraising is harder than software, very probably, because everybody knows hardware is hard. It takes a much longer time to get to a certain revenue, especially when it's deep tech. You invest a lot of resources in R&D and so on. So our own fundraising trajectory was not easy, but we could do it. So we raised around 36 million euros in 2 rounds. The first one was 16 million, and the second one was 20 million. But also there we see that most of the money is coming from outside of Belgium. Because in Belgium they expect quicker return, and it is risky, But okay, that's part of innovation, of course. If it's not inherently in the culture to take risks and to try things, and they can, of course, not work out. We see that a lot in Silicon Valley. Then you create innovations as such. So if culturally it's not so much part of the culture, then
it becomes a lot harder.
It doesn't happen. It doesn't happen.
And how is that? Maybe this comparison is too easy, and I might be wrong. But how do you compare it? For instance, I'm from West Flanders, but in West Flanders you have a few manufacturing companies who are in their niche world players. For instance, Picanol or Parco, which are hardware companies in relatively big industries. How come they have been able to do that in the past, but it's not something we apparently seem to be able to copy in the future?
Well, I think that...
Or is that two different businesses? Is it uncomparable?
I think Picanol also relates to our older history where we were specialized, and especially in the region of Kortrijk, in fabrication and so on. A lot of that industry also was expelled, has been migrated to the low-cost countries. But they were smart enough to keep a lot of knowledge in-house around fabrication or textile fabrication. So it's a historic thing. So at a certain point in the past, many decennia ago, they saw an opportunity to develop a certain technology in terms of textile fabrication, and they kept the research and the knowledge in-house. So as a result, we still have, luckily, companies like Picanol right here. It's a foundation from our past where we saw the opportunities for innovation in a certain direction. The same, but in other domains, we don't see anything, of course, like electric cars or companies specialized in AI, very limited. You have a few companies who are using GPTs and someone else's technology, but we don't have any company like OpenAI, which is basically starting fundamentally with the development of AI systems, similar to battery systems and so on. How did it start? It is always a matter of putting a number of people together who can share disciplines and who are able to take risks. Why Google created Google? What's the name of their experimental division?
They have Google X, they have Google
X,
Ventures,
yes.
They have Google
X.
Okay.
So what's happening there? They said, okay, a number of people here have good ideas, but they don't have time to experiment. Let's give them like a Friday to do their experimentations, to try to bring their ideas alive. And what you see is that a lot of initiatives are started. Of course, most of them never see daylight, of course, but a lot of great products from Google were basically created.
Waymo is one of them, I guess. No?
Waymo is one of them.
Yeah.
Also, I think Google Calendar was one of them. I don't know for sure, but there are a lot of them that were basically created,
side projects.
Side projects.
Yeah.
That's also a cultural thing in the company. We try to do that as much as possible because in the core, Magnax is an R&D company. So we have to give the people time to experiment, to do trial and error, because also at university, it's not really endorsed to fail.
Yeah,
that's unfortunately still the reality. And innovation comes up via trial and error, and without error, there is no trial and error. So you have to be able to do experiments and fail. And that has to be incorporated into companies in certain domains. And if you don't do that, the countries who are making that possible create companies like Google.
You've been able to manage raising funds yourself, even though you're in Belgium and in Europe. The funds didn't come from Belgium per se. But what if you would say, because 36 million is a lot of money, but compare it to other fundraisers, it's relative.
It's small if you compare it.
I don't. But what if you, let's say it's small, but what if you, because now it's also because you're focused on R&D, but what if you would say we want to start manufacturing, which is even a lot more expensive to get those? Do you think it's possible even if you would say we want to do that?
Very good question. I think if we were located in an environment where the ecosystem would support that more, as for instance, the venture capital ecosystem, we would probably do it.
But so today you're saying we're focusing on R&D because of the ecosystem, because we don't have the right context.
For us, it's smarter to focus on R&D because we're good at that. And we know also that larger corporations are looking to in-source technology, but they have the capabilities to be very good at producing these things. But if you want to really create a lot of value in Belgium, Europe, you should also try to deploy manufacturing facilities, and that brings a lot more value for the ecosystem here. We decided not to do that for strategic reasons. If we look, for instance, at Figure, they raised recently around $700 million. I can imagine that they're already thinking of preparing a production facility for their humanoid robots, and to avoid that, it happens only in China. That kind of manufacturing. It's also a matter of manufacturing. We were maybe specialized in that some time ago, but all the manufacturing was migrated to Asia Pacific region, and now a lot of manufacturing, tooling, production knowledge is located there.
You don't have the knowledge anymore,
You have to be able to attract tooling engineers, for instance. You have really, really good tooling engineers in China. Not sure if you can find them in Europe. So that's a bit of a typical problem that you have if you want to bring back things like production, manufacturing to Europe.
And do you think we should bring it back?
Not per se. It's a good question, of course. In the US, they say, okay, we have to bring back manufacturing because manufacturing, it's a large group of people who can be employed by that.
And you create some independence as well. Definitely giving the geopolitical instability. If we have to depend on China for the rest of our lives, I'm not sure if that is what you want, but okay.
Yeah, that's a very good point. I think you have to bring it back, but you also have to take into consideration, into account that a lot of that manufacturing will be done not by humans, but by AI systems and robotic systems. So you have to experiment with trying and manufacturing small series, for instance, and to be able to scale it up locally via automated systems. You have to invest a lot in these new technologies, such as robotics and AI, to be able to indeed manufacture locally.
And do you think, let's say I'd like to start a robotics company. I want to, in Belgium here, do a Figure-like company. What would I need? Would you say don't even start? Or would you say, okay, maybe these and these things could help you get pretty far? Or what's your... Because I don't think there's a lot of experience, or I don't know a lot of people who have that like deep tech, like literally hardware and complex hardware experience. In other words, would you do it again or not? How would you... Let me say, I want to start Figure here in Belgium.
Yeah, that's an interesting question. I know that Brad Adcock, the founder of Figure, he started with an aviation company.
Archer.
Yeah. He also was a bit lucky with the timing because he could still IPO that company at the right timing. So he could also...
He cashed quite a lot.
So he invested also personally, I think $100 million for his new venture, Figure.
Yeah, he recently published something that he the first 6 months he pushed over $1 million every month himself from his own pocket. Yeah.
So if you have a starting capital of 100 million, you can attract the best people in the world. Yeah. So if you want to start a very complex project like that, there is nothing else that you just need the best people possibly to start something like that. Mm-hmm. And for such a complex project, it's like a car, in a humanoid, like a car, you need at least 30, 40 people to start with the design process. You need this very different disciplines. You need software, you need AI specialists, you need motor specialists, you need gearbox specialists, you need sensor specialists. You have to bring them together at a certain spot where they also want to stay, of course. Mm-hmm. You also have to think about the supply chain. We source a lot of components also from China. But you need access to a company like OpenAI, I think. I'm not sure what figure is using.
As far as I know, because I'm not sure if it's all public, but as far as I know, they have their own action models, because you have large language models, but you have like an interpretation of it, which is learning to do actions and copying actions. Mm-hmm. But they also have an integration with OpenAI to do interpretation of communication of people. Like there's the one video where there's a guy saying, okay, can I have that apple? And to do the recognition of the apple and then interpreting what he means, that's OpenAI. But the actual action, that's in their own, as far as I understood, because they're not publishing a lot on it. Yeah.
But to come back to your question, I think it's possible because we have a lot of really good engineers and researchers in Europe. So it's not a matter of that kind of resources. If we have some money to start with, I think it's feasible because.
So what you're saying is step one is 100 million. Small step.
Plus minus.
Step two.
To attract
the right spot. So probably not the center of Brussels, but somewhere where people can. And what's important for that spot?
Close to university.
Close to university, so Ghent or Leuven.
You have like Ghent University has a robotics department, but of course they're not going to give us their best researchers. They want to keep them also, of course. So you have to find a way to assemble the people to extract.
For that part, you have the 100 million to attract them.
That's how it starts, because the individual components can be sourced globally. But a very good core team is basically
that's the starting point.
That's the core.
And why 100 million then? Because now you said a team of 40, let's say they're well paid, 200K per year, so that's 800K per year ish. Mm-hmm. $1 million, more or less, for that team. My mathematics are quite wrong here. I'm talking about 10 million, not 1 million, but 10 million a year. 100 million means a runway of 10 years. You need a lot of hardware.
You go much quicker through that money because it's not only the
I'm thinking in software probably.
Yeah. It's supply chain, creating components, prototypes costs a lot more than you try to work as much as possible with off-the-shelf components, of course. But as we have seen also with Archer, with Figure, many of these components were not good enough, not light enough, not compatible enough, so you have to basically create them yourself.
And that's what you have to do with Magnax as well? You have to build all those components yourself?
With Magnax, it is very fundamental. The whole motor is basically fully created in-house. So it's we start with copper, with iron, with magnets.
You have it melted
and you create a motor with that.
Okay.
Of course, we use suppliers to create like the windings. You have to have special machines to do that. But a lot of the tooling and the machinery, you have to also create that. You have to create the machine that creates the machine, which means that's also a lot of IP that you integrate in-house, which costs a lot of money to create. So you need also specific engineers for that, the tooling and so on. Also securing patents. costs a lot of money. You have to keep them alive. Everything costs money, basically.
Now I get the 100 million.
In hardware,
it's a different
you go
different
much quicker through the money than with software. Yeah.
Yeah.
Also, in terms of revenue, with software you can put out alpha, beta versions. Customers are willing to pay for it, and together with you can fine tune it, can optimize it. With hardware, you are taking risks if you put something into the world which is potentially dangerous. Liabilities. That's also a different ball game.
Yes. Yeah.
So it's a different ball game, but it's not impossible. I think it's very feasible. It is feasible to do it also in Europe. I think we have to do it in Europe because otherwise we are just the sick little brother of the world, the play ball between US and China.
Mm-hmm. And does that mean you are thinking of something like that or hoping for something like that?
If I would meet the right people, I would be quite interested to do something like that. Yeah.
But you're not seeing. It's not like that there's others that kind of company there. They're working on it. There's nothing we don't know yet.
I have been talking with a lot of people who can create pieces of a humanoid robot. If we would bring them together, it would create an interesting situation. Yeah.
This feels like you're working on something. Okay, so that sounds very interesting. Maybe a conversation we can continue after the podcast. But that being said, so the ingredients, 100 million, a place. And then we have the rest, the talent we have here. That's basically what you're saying?
Yeah, we attracted this. So we also have, I said, 17 nationalities, people from everywhere around the world. If you have a really interesting and important project to do, the engineers or researchers are coming to you.
And then fundamentally, my question is, why didn't it happen yet? It sounds like, 100 million is it purely because 100 million is just a lot of money and it's extremely hard to find in here?
I would not pinpoint too much on specifically 100 million. That's the starting point for Brett. Also, I think in the San Francisco area, everything costs a lot more money.
Yeah.
Rent and also people. Starting point could also be a lot less money. But at a certain point, you have to create a prototype which is impressive enough to get access to more funds.
Yeah.
Because this is also deep tech. And eventually, you want to go to production. Now they have 700 million. He says, okay, that's more money that we actually need. Nevertheless, we're gonna use it to accelerate the road to production as much as possible. So yeah, I think access to resources like that is a starting point. Yeah.
So to me, it also feels, to be honest, that besides all of these things, the fact that you are experienced in hardware is also a big asset. That maybe is also a reason for Brett or Elon Musk or others to have that experience in hardware.
He had experience in hardware with Archer, of course. So,
which is something which is quite seldom in Belgium and Europe. Maybe a bit better, but in Belgium it's very seldom.
Yeah, well, I think the hardware aspect we can cover it. The AI aspect is still unclear for me. How deep you have to go on that level. You can say a lot more about that because you're already in that world for a long time. An interesting thing to talk about in a later stage.
Yes. All right. Cool. Now, that's what we're seeing happening right now. How do you think this will go into the future? How do you see this moving forward?
I think, to give you one example, I had a meeting with my accountant this morning. He has 6 employees, and I was also, he's not very technological minded, but I was asking him, okay, how do you see the rise of AI? And he also said, okay, to be honest, a lot of the tasks that my employees are doing at the moment, like booking in things, it will be quite easy to automate it in the future. So I can expect that he started alone and that he will end up alone because AI agents will cover most of the job activities that his employees currently are doing. So in the future, I'm thinking about my kids. How can we make them ready for the changes that will happen. If we see in the US that 1.1 million people are active in some sort of transportation, taxi drivers, lorry drivers, and so on, and autonomous cars can cover for that.
Yep.
You cannot expect that a taxi driver will become a data scientist or something.
Yeah.
So
but to come back on your accountant example, I was just thinking, will he end up alone? Because I think there might be a different effect. If things become cheaper, it also becomes more accessible because you have an accountant, but not everyone has an accountant. You have an accountant because you're an independent. And in Belgium, usually independents have an accountant. But if you're not independent, most people don't have an accountant to do their taxes or anything. Yeah. But the moment, and that's also because it's relatively expensive. As an independent, it's an easy cost.
It democratizes.
Yes, so it makes that a lot more accessible for everyone. So I can imagine if my sister, who's not an independent, if she can have access to an accountant for a tenth of the price, she might not do her taxes herself anymore, or even her budgeting. She might just say, please, accountant, for that price, you can do it for me. And there's still a contact person who can have a lot of clients. But so their profession might change a lot more to understanding the person. And then the actual accounting work becomes a lot more accessible for everyone. So in that sense, if you look at the economics, if prices drop, usually demand increases.
Yeah, that would be a good thing, of course. If your sister,
maybe I'm naive,
your sister now has access to an accountant, she doesn't have to invest time in accounting, and she can dedicate more time in her real job and increase her revenue as such. Which, if you look at it at a large scale, increases the GDP of a country, for instance. So from that perspective, we can expect that GDP will grow because of productivity increase thanks to AI. Nevertheless, a lot of people will probably have no job in the future.
So that's something you expect?
If you can start using robots and AI for more than most of the job activities that we do today, people can dedicate more time to other things besides their job. People will also always try to have some sort of value in the economic system, of course. But for some people, what do you think? What would be the future of a taxi driver, for instance?
But the thing is, I don't see a person as their job. I see a person as a person, and I think a person can do a lot more than they usually think.
Exactly.
I think people underestimate themselves quite a lot.
Yeah.
So I think and from that perspective, that's one thing which I think. So I don't see a taxi driver, but someone who can do other things and learn. I think people can learn more as well than they think, but they have to be open for it. I think that's the challenge. That's at least a big challenge. And something else that I'm thinking is, I wonder, the same thing with universal basic income and with the idea of people don't work. Most people that I know who take like a sabbatical or anything like that, or you have those people that exited and that got quite a lot of money, usually they don't stop with doing everything. People, in my opinion, people need things, projects, goals, things that they want to build, do to achieve something, and usually want to be paid for that. But the way in which you do it might change. I think one of the big themes that I see that already is picking up is like the idea of the influencers. That is something which is, I would say 10 years ago or 20 years ago, or my grandfather, he would have probably said like, who has time for this?
Yeah.
That's not important, but we're becoming in an economic situation where we have a lot of luxury, we have a lot of time, and then these things start to arise. They create value in a very different way. And with universal basic income, I struggle with the idea if everybody has the same amount of money, that amount of money becomes worthless. I don't. So I find that, but of course, it's very philosophical and theoretical.
I think if you look at it at how it is, like an economic system relates to scarcity of labor and scarcity of knowledge. So labor has been already displaced a lot by machinery. So that thing was solved, but now what we see is that the scarcity of knowledge is getting into problems. So what's the value of a lawyer if you can basically use an AI immediately to do his job? You can say, okay, now the lawyer has time to do his hobby, like drawing or something. But okay, that doesn't have much value into the economic system. It has a lot of value for him, but not for the economic system. So a lot of things will be done by robots and AI in terms of economic growth, which means a lot of time will be available for people who doesn't have to be part of the economic system by definition, because growth will be there anyway, because the productivity increases a lot thanks to the systems that we are creating, the robotics and the AI systems. And that is creating the possibility for universal basic income, for instance, to have at least to give everybody some money to survive, basically.
Yeah, but then you'll have like, there's so many things which influence that, because everybody has the same money. Why would a shop not increase their price a lot so that you can't buy a lot anymore? So that will become a very strange play, and then you need government control on top of that, which is not something you would want. Yeah. So
that's a very unclear situation. I think if things like knowledge, energy, labor becomes basically super cheap, what's still there? Equity. I can imagine that we will start creating a world where you have two kinds of people, the haves and the have-nots. The haves will have equity, basically the owners of the AI systems, somebody who has houses. People still have to rent houses, of course, so you still need like money to pay people. And then people who were dependent on labor for their income, that falls away. So yeah, they don't have equity.
But at the same time, the idea of that the solopreneur unicorn will happen is positioned as well. So that means if you say that is possible, so that means that every individual can become an entrepreneur because they have access to technology. We can make them scalable. So that feels. How do you put that next to each other?
Yeah, I'm not sure if everybody wants to become an entrepreneur or a freelancer. Maybe there is a certain percentage of people who would like to do it, but they are stuck. But you have a big percentage of people who are not ready for that, not willing to do that, who are very happy with their secure job, which falls away. So there will still be a large portion of people who will never become freelancers or entrepreneurs or anything like that, for who we have to take care of by definition.
Maybe on that one, so there's a lot of moving, and it's fairly hard to impossible to predict the future. But what if you could wish or say, okay, that's how I would want it to look, but pointing at a dystopian version of it and a utopian version. But let's start with the dystopian one. What's your worst case scenario if things go south? How do you see it evolving?
Dystopian, that's of course, there is a movie, Ready Player One. If you remember that,
no.
It's already 10 years old or something. And
to me, it sounds like the Tekken Ready.
Yeah. So it's about the rise of AI and the fact that most of the labor is displaced by robots and AI, and you have a huge portion of people who are basically useless as a result of it, not part of the economic system anymore. So you have to keep them busy. So what they do, they create virtual realities,
bread and games,
to keep them busy.
Or
keep them busy.
Yeah.
So some people are still like super happy because they are a champion in their specific virtual reality worlds. Ice hockey, anything can be anything. The dystopian version would be indeed, I think, that most of the humans, most of the people, are just busy in their virtual worlds, and that's it. the utopian situation.
So you would have a very big group of people living virtually just from behind their desk or sofa.
Yeah, sitting in their rooms maybe and just in their virtual world, and then they eat and drink when it's necessary. But for the rest, there's not much to do or to see besides their virtual reality glasses.
And then another part of the world will enjoy the world in reality then, or?
Well, there will be people who will have equity, owners of companies, owners of
the happy
AIs,
few then.
Owners of real estate who can do whatever they want, who will be able to deploy a palace for their own, have access to a lot of resources, who will have access to, anything. Can also be more choice in terms of partners and so on.
Very big difference between...
Big difference between these two groups of people, actually.
Yeah.
Utopian would be that we become more social system from that perspective, and that we use the technology to take care of creating and keeping up with innovation, growing the economy as much as possible. A lot of, especially the boring jobs, are displaced by robots and AI, and that people have time for their hobbies, and that they have time to create communities, because at the end, that's how humans started. In the long time ago, we lived as groups from 50, 60 people, and we were very happy as such because we had a continuous interaction with each other. Isolation and all the depressions that comes from that didn't happen very much. People were living together, and if we can create again that kind of communities where people are interacting with each other, helping each other, that would be a utopian version of the future. But the AI will be there, and the robots will be there anyway. So we cannot avoid that.
Mm-hmm. Yeah. All right, cool. Daan, thank you. It was very interesting, and happy to continue that other conversation.
Yeah.
Thank you, everyone. Bye-bye.